Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM and IFM and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam FM on financial mathematics. The current spot interest rate curve is as follows, and you have interest rates for a quarter of a year, half a year, 3/4 of a year, 1 year, 1 1/4 year, 1.5 years, 1.75, 2, 2.25, 250, 275, and 3. And this is not directly stated, but you can see that with the structure of interest rates, these have to be using the same time unit for the interest rate. So all of these, we'll assume, are annual interest rates. Annualized, but specific for these time periods. So spot rates for these maturities, but annual rates. Raphael has a 1-year loan for $1 million with principal paid at the end of the 1-year period. The loan has a variable interest rate that resets at the beginning of each 3-month period. The interest rate will be the spot interest rate at the beginning of each 3-month period. So, looking back, what we would call in arrears if we were talking about a swap. And Raphael enters into an interest rate swap where he is the payer with the characteristics of the swap exactly matching the loan. So the swap will be also settled in arrears. Determine the quarterly swap rate that Raphael will pay. And that quarterly swap rate refers to a rate that is a fixed rate that will be paid. So whoever pays the fixed side will pay. Raphael wants this because he will receive floating payments that he will make on his loan. So he is swapping these floating payments for fixed payments. Kind of standard idea when you enter into a swap. In the answer choices, we have the symbol BP. That stands for basis point, not basic point, basis point. Or basis points, and most of the time when it's plural people write BPS, but anyway, and people call them beeps also. We use the standard formula for the fixed rate of a swap, but applied to the quarterly interest rate. And what is the standard formula? Well, it's the fixed rate is equal to 1 minus the price of a zero coupon bond maturing at the end of the swap, divided by the sum of the prices of the zero coupon bonds that correspond to times of payments. And in this context, it will be the rate over time unit, which is the time between payments. So it will be a quarterly rate that we will get. So that is a confusing part of this problem. The rates given are annualized, but you will have to figure out a fixed swap rate as a quarterly rate. But anyway, we just use you can kind of guess that has to be the case because you can see that the answer choices are much less as interest rates than the rates given for the spot yield curve. So the spot rates are well over 1%. In fact, all of them are over 1.5%. So how in the world would the fixed rate be so small? It's not. It's a quarterly rate. But that formula that we're referring to for the fixed rate of a swap gives you the interest rate per period between two payments of the swap. And the payments are at time 0.25, 0.5, 0.75, and 1. And we just need to figure out the price of a zero coupon bond that matures at time 0.25. So with maturity value of 1, what is the present value? Well, we just use the spot rate applicable to 0.25 years, to 0.5 years, to 0.75 years, and to 1 year, and we discount using those spot rates. In each case, we could have written this as 1 times the interest rate to the power negative 0.25, negative 0.5, negative 0.75, and negative 1, but multiplication by 1 is irrelevant in a sense. It doesn't change anything. So the prices of these zero coupon bonds are as listed. Now it's just a calculation. We get approximately 0.0047612. That's 0.47612%, or about 48 basis points. And that's answer C. Please remember this is copyrighted material. This comes from the study note of the Society of Actuaries, belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.